So low latency trading systems, we're finally going to understand how an exchange works under the hood, how you can build something like Zerodha on your own. The video is going to be divided into two parts. The first part is going to be a high level system design of Zerodha and a little bit of finance jargon that you need to know if you need to build a system like this. The second part of the video is going to be us coding an exchange, applying all the knowledge that we learned in the first part. And there is an assignment at the very end, which is sort of an algorithmic problem. So if you want to practice your DSA skills a bit, the assignment is for you. The goal of the video is to take you from 0 to 1 on how you can build a core finance system. With that, I'm super excited. Let's get right into it. All right, let's understand the functional requirements of an exchange like Zerodha. When you go to the Zerodha app, after you sign up, the first thing you have to do is KYC yourself, which means you have to provide your Aadhaar or a PAN card because the exchange needs to make sure you have a demat account and you're a citizen of India. Once all of that is done, is when you reach a balances page where you can basically see that you currently own nothing. You have 0 rupees in there. You have 0 stocks of Tata, let's say, 0 stocks of Axis Bank, so on and so forth, because you've just signed up. The next step usually is that you go to your bank account and you transfer some money in here, let's say rupees 10,000. And now your balances will show that you have not just 0 rupees, but around 10,000 rupees. And now you can trade with it. What does trading mean? Well, if the stock of Tata, let's say, is trading at rupees 100 a share, you can go to Zerodha and say, hey, I need to buy 10 stocks of Tata, which would mean your account will get debited by rupees 10 into 100, which is equal to 1,000 rupees. And your account will get credited with 10 stocks of Tata. Now you can hold on to these stocks for as much as you want. And let's say the price of the stock goes up. The price of the Tata stock after a year is 110 rupees a share. And then you can sell your 10 stocks. And by the end of it, you will have 0 stocks of Tata again. But you will have rupees 9,000, which is what you were left with, plus 1,100 rupees that you just made by selling the stocks of Tata at a slightly increased price. And with this profit of 100 rupees, you can transfer it back into your bank account. You can trade more with it, so on and so forth. That's the high level requirement of an exchange. It should allow users to put money in there. Once they've put money in there, they can buy and sell various stocks that are listed on the exchange. How does an exchange work? Let's recap this really quickly. An exchange needs to allow users to sign up and sign in. User needs to KYC and connect their demat account. User can place an order. There are 2 types of orders, a limit order and a market order. What are these? These are finance jargons we will discuss very soon. And the users can see their balances, how much Tata they own, how much INR they own, and their open orders. Now this open orders is very sort of closely related to this limited market order section. So we will discuss this very soon. If you don't understand it yet, it's fine. This is all the finance jargon we need to go through first before we can actually start building an exchange. Curious questions to ask at this point. If you've ever looked at the Zerodha application, one question you might ask is, how is the price of a stock determined? Does Zerodha say कि हाँ, Tata stock is worth rupees 100? Does Tata itself price their stock at a certain point? Or is there something else that decides the price of a stock that's so volatile in nature? If you've ever looked at trading graphs, they go up and down really quickly. How is the price of real estate determined? Let's leave exchanges or stocks for a moment. How do you do this in the real world when you're trying to buy, let's say, a plot of land or a flat in a specific society that's not being sold by, the owner of that specific apartment or like the builder of that apartment? It's out in the open. It's an open market. There's a sector that's been there for a few years now. How does trading happen? How does the price of a land there get decided? And the answer is supply demand. Now, this is something you might have heard, ki haan, supply demand is what causes price to up and down. But what does this exactly mean? Let's try to understand it. So when you're in the real world, let's say you want to buy a plot of land. The way it usually works is you go to a broker, you tell them, hey, I'm willing to pay 40 lakh rupees for this plot of land. And the broker sort of keeps a tab of that, tries to contact the other party, which is the owner. So this is the buyer. And the owner comes back with some sort of an offer, okay, hey, I'm willing to sell it at 42 lakhs. And then the buyer sort of decides whether or not they want to go through it. Somehow these things converge. But assume this happens. Okay, there is one very hot property, and there are a bunch of bachelors who've currently flocked to this place and really want to rent that property or buy that property. What will happen is the number of buyers will go up. So when these buyers will see that, हाँ भाई, there is someone who's put up an offer for 40 lakh, they'll be like, no, I'll pay 41. The other one will be like, I'll pay 42. So you can see this side is sort of very heavily, there's a lot of demand here. There's not enough supply. This is what happens in Bangalore. This is why the real estate prices in Bangalore went up so by so much. If you look at it from a high level, it's like, a very crowded city, roads aren't great, floods can happen from time to time, yet the price is up so much. Why? Because there are a bunch of bachelors that flocked into that city. They all need houses, hence they need to either buy houses or rent houses. There's a lot of demand. There isn't enough supply. So when the owners sort of have power, they can keep pricing up because they know that there are 10 different people waiting to buy this property. This is what people mean when they say that supply demand is what determines the price of a stock or the price of a real estate property. Long story short is, if there are more people on one side, the price will go up because they're all competing against each other to buy that thing, and vice versa. If there are a bunch of people who are trying to sell property and not enough buyers, these guys will drop their prices down more and more so that someone eventually buys it, and they'll try to outcompete other owners. If there are two owners who have exactly the same house, if one will price it at 40, other will come in at 38 lakhs, so that whoever is the potential buyer will take the 38 lakh house. So this is how supply demand causes the price of a stock, of a real estate asset to go up and down. And this is how even stocks in the real world or even cryptocurrency prices go up and down. It's pure supply demand. How much do people want an asset? And usually the supply sort of increases, as in case of real estate. It happens if a lot of people flock to the city. In case of stocks, if there's certain news that came out, if there's a lot of profit that happened to a company, suddenly a lot of people want to buy, not a lot of people want to sell because let's say the company had a great quarter, is when there is this arbitrage and the price sort of goes up. Right? That's a very theoretical explanation. In more technical terms, you need to understand these few finance terms in case you need to understand a little bit better as to how markets like these are organized and how supply demand arbitrage sort of looks in the real world. The first term you need to know about is called the order book. Then there is something called the limit order and the market order, the same thing I discussed a few slides ago, which is this thing right here. Something called the market depth and the market liquidity. They both sort of mean the same thing and can be used interchangeably. And finally, what is a maker and what is a taker when an order happens, when an exchange like this happens, someone tries to buy a house or a stock. Let's understand the first term here, known as the order book. Let's take an example of Bangalore again. Let's say there's a certain plot of land in Indranagar where there are 8 plots and they're all identical, which means they all look the same. There's no real corner plot, even though it looks like there's a corner plot here. Assume they all look exactly the same, similar to a Google stock. If I have 10 Google stocks, you have 10 Google stocks, we sort of can get similar value from it. Assume that is the same case for all 8 of these plots. How does a buy or a sell happen on this specific asset? If you are the buyer, you give your best price to a broker. Let's say you say, I'm willing to pay 40 lakh for one plot of land. The broker says, okay, I know there is one quantity someone is willing to buy for 40 lakh rupees. He sort of puts it in a book. And then let's say some seller comes in and says, hey, I'm willing to sell it, but I'll sell one for 42 lakh rupees, nothing less than that. As you can see, there's this broker sitting in the middle, sort of keeping track of who are willing to buy, who are willing to sell, and how much are people willing to buy and sell for. So this one will be a red circle, this one will be a green circle. Someone who's willing to buy is usually green in trading charts. Someone who's willing to sell is red. They're maintaining this book, and that's sort of their high level purpose of the broker, to maintain a book of how many trades are people willing to make at what price and how much quantity are they willing to buy. At some point, these will converge. The buyer will be like, okay, I'm willing to go up to 41 lakh. Seller will be like, I'll go up to 41.5 lakh. And eventually the spread sort of closes is when the exchange finally happens, that the house goes to the buyer and whatever 40.5 lakh rupees goes to the owner. But throughout, the broker played a really important role. The broker is what provides a central place to buyers and sellers and gives them this central book to look at. This is what's called the order book, a place that's publicly available that shows all the bids and the asks. What are bids and asks? This person is bidding, I'll pay 40 lakh. Someone else might come and be like, I'll pay 40.5 lakhs. As this list goes bigger and bigger, there is one green side which is called the bids, which is how much people are willing to pay. There is one red side which is called the asks. How much are people asking for a certain asset? And at some point, when these converge and the spread closes, or someone goes up, other person goes down, is when the exchange actually happens. And those orders move off of the order book. The order book is the current set of orders that are not matching. There is some gap. Someone is asking for more, someone is paying less. When the match happens, these orders move off of the order book and the real world swap happens, which means asset moves from one person to the other person. The other asset swaps again. What are these assets? INR Tata stock is one such what's called a market where you can swap Tata stock for INR as long as they converge at some point and the broker says, "Ki, haan, this person said he's willing to pay 100 rupees. This person said he will accept 100 rupees for one stock. Make the swap." That's how the Tata INR market sort of prices itself. If the same thing applies to houses, the same thing applies to a Google stock, same thing applies to Bitcoin, INR. All of these are markets which are effectively stored in order books in exchanges. When a match happens is when you can say that the price of a stock is a certain number. How do you determine a price of a stock or a land? The last price at which an exchange happened is what's considered as the price of that stock. For example, let's look at the real world order book. Ignore this one. Let's look at the BTC USDT order book, which means the Bitcoin USDT chart on Binance. This thing is a real world order book. What I made before was like nothing. No one really uses order books in traditional realtor/buying houses. But when you're buying stocks or you're buying Bitcoin on a centralized exchange, you use an order book. And as you can see, the order book here, it says, okay, there are a bunch of people who are willing to sell at 28,312.11, 28,312.53, and a bunch of more. These are the quantities that they're willing to sell. The first person, this isn't necessarily one person. It could be one person who's selling one Bitcoin, another person who's selling another Bitcoin, another person who's selling like 110.7. This could be the three people who are willing to sell at this price. One of them is selling one of them is selling one of them is selling 0.7 Bitcoin. And this is the top of the ask side of the exchange. Okay, we are asking this much price for this much quantity. And what is the bid side? It is, bro, we are willing to pay only 28,312.10. As you can see, the spread is really small. It's literally 0.01. And that's usually true for more liquid exchanges like Binance. Okay, their order books are extremely liquid, which means you will see the spread is really small. Feel free to take a pause here and try to look at these numbers, see how they go up in number here and down in number here, because you want to show what is the best price someone is willing to buy it for, what is the maximum they can pay here, and that price keeps on going down. Similarly, what is the best price someone is willing to sell it for, which means what is the lowest price someone will give away this stock for. Those are what are sort of kept close to each other here. And the thing that you see in the middle is the current price, which was what was the last price at which a trade had happened. This is the current order book. These people, as you can see, are not converging. This person is strict and saying, I'll only buy for 0.10. This one is like, I will only sell for 0.11. This match hasn't yet happened. But in the past, a few milliseconds ago, there might have been some people who would have converged. Okay, chalo, theek hai bhai, let's do the exchange. One of these parties sort of gave in and the exchange happened, which is why the current price, as you can see, is 28,302.11. Similarly, let's look at a Zerodha order book. This one is for Axis Bank. And as you can see, this is aftermarket, which is why it's not extremely liquid. All of these quantities are sort of zero. But there are still some people who've placed order aftermarket. This person says, I'm willing to sell my Axis stock, buy an Axis stock for 1008.05. This person says, I'm willing to sell at the same price. There's not one person. As you can see, there are multiple orders here, which means multiple people have put these bids and asks. And the price is same, yet they haven't matched. Can you guess why? It's because it's aftermarket. You can't really trade aftermarket. You can still put in orders, but they won't really execute until the market opens. This is a pretty sort of illiquid/empty market on Zerodha right now. Why? Because it's aftermarket. No one's really placing orders. When I would look at the same chart during the day, I'll see a bunch of bids and a bunch of asks. The order book will be much more populated, just like the order book here is like pretty populated. There are actually much more orders here. If you keep going up, keep going down, it doesn't show you a bunch of them. But if you go to the very top of it, there might be some idiot who's like, hey, bro, I will sell my Bitcoin for $10 million. One quantity, please. And there might be some idiot on this side also who's like, okay, I will buy Bitcoin for $0.0001 with like 10,000 quantity. Can you guess why? It's because a bunch of fat finger errors happen from time to time. A bunch of times some trader will, and eat the order book, put an order by mistake. And when they're starting to eat the order book and, the market, let's say, isn't too liquid and all of these get eaten up, they'll end up eating up this very irrational order as well, and vice versa, which is why you'll always see at the top and the bottom of an order book a bunch of pretty irrational orders. All right, the next question you might have is, what determines the price of a stock? If someone says Google stock is worth 200 rupees today, what does that even mean? Is it the average of the Google stock that people bought in the last 1 year? Is it the average of the last 1 day? And the answer is no. The price of a stock is literally the last price at which an order happened. There are multiple exchanges all around the world. There is Zerodha, there is Grow, let's say, and both of them have their own, let's say, whatever, Tata INR market. They have their own separate order books, and Zerodha's price will be the last order at which they were able to match an order, which means, let's say, whatever, 200.1 rupees. And Grow might be like, bro, on our order book, the last order that happened at 200.5, let's say. So different exchanges could have different prices of an exchange of a certain asset. What is the actual real world price? It's, you basically take inputs from all of these exchange and try to figure out what the current actual real world value of this asset is. But each exchange has its own price of a specific asset. And how is it determined? It is the last price at which an order was able to execute, which means at least a few milliseconds ago, few people were like, haan, theek hai, le jao. Let's make the swap at this price, which means this is the current price. This might be the price at which you'll be able to buy or sell, or like a little bit more, a little bit less. But a few seconds ago, an exchange happened at this specific price, which means this is the price that we feel is the fair price of Google, of Facebook, of whatever stock. Moving on, how do you fill this order book? I kept on saying the order book is the place where you maintain this list of orders, which is basically the price and the quantity that someone is willing to buy or sell at. How do you actually place this order? And this is where we understand the very first type of order, a limit order. Now, when you go on Zerodha, you might just swipe a button saying, oh, I want to buy 10 stocks of Google. You swipe a button, some INR gets debited and you get 10 stocks of Google. That does not happen when a real trader is sort of trading on the platform. Real traders put very specific price targets, which means they say I'm willing to buy 10 stocks of Apple, the quantity, but this is the price that I will buy it or sell it on. And this is the thing that effectively reaches the order book. When you place an order, you simply say, bro, give me whatever the current price is. Somehow the centralized exchange figure out what the current price is and gives it to you. But in case of a limit order, which is what traders put, the traders say this is the price quantity couple I need to buy, which means I'm willing to buy 10 stocks of Google at 200 rupees per stock. This, if there is a match that's present on the current order book, the order gets filled, which means this order never reaches the order book. But if it is a pretty irrational price, let's say that it should sit here or it should sit here. Even if it should sit here, if the match did not happen, the order goes to the order book and sits there until one of the party budges and someone actually takes that order. It is usually used by traders, has some trading fee associated with every order that matches. So usually there is no trading fee for you to put an order on the order book. When your order actually gets matched, which means you actually do a swap, is when the centralized exchange will take some trading fee. And if you go to Zerodha, this is what their UI looks like. If I have to buy Axis Bank and I have to do a limit order, I say I'm willing to buy 10 for this specific price. And if I click on buy, if this specific order can immediately be filled, which means if there is someone who's selling at this specific price, then the order will be filled. My order will never reach the order book. If that is not the case, so let's say the best selling price is much more than what I'm willing to pay, this order will sit somewhere in the order book. Then somehow during the day, it might happen that this order gets matched. It might happen it does not get matched and keeps sitting on the order book, or eventually I just cancel the order. So this is the first type of an order, a limit order. What is the second type of an order? A market order. This is what as retail sort of put in, which is if I select market order here, you will notice there is no price. I don't ever give a price. I simply say I want to buy 10 stocks of Axis Bank. Click on buy. Under the hood, still you sort of buy that from this order book only. There are some people who are willing to sell. They sort of put their orders here on the order book. Under the hood, you're still eating up this order book somehow and giving that specific INR and getting back that Axis Bank account, but you don't see it. You basically say, bro, give it to me for whatever price is currently the best price on the order book. I will take it and I'll be happy. I don't really need to deal with an order book. I don't understand an order book. And that is how retail usually buys. They click on the buy button. They see a specific quote. Okay, if you want to buy 10 stocks of Axis, you'll probably have to pay 20,000 rupees. The person is like, okay, I'm fine with it. They swipe a button and this swap happens. Under the hood, what is happening? Still the order is reaching the order book and bunch of these orders are getting filled. This is how sort of retail ends up eating the order book, and this is why sort of the price that you'll see here will be much worse than the price that a trader sees. By price, I mean the fee that the exchange might end up taking. Just for giving you a pretty UI where you don't have to understand what is a price and what is an order book. Just for giving that pretty UI where you click on a swap button and the swap happens, usually the trading fee here is much higher than if you simply placed a limit order or went to the order book and said, I'll try to eat this specific last best bid at the moment. Ask at the moment. If you do that, that is usually much better than trading from this swap UI, but retail does not understand it, which is why a lot of retail just trades from simple swap UIs and ends up paying a lot of fees. That's what a market order is. It is used for buying a quantity off of the order book, irrespective of what the current price is, usually used by retail, usually preceded by a get quote request. So the thing is, as I said, under the hood, it's eating the order book. If you, without looking at a quote means ke bhai, I will give you 10, but you will have to pay 20,000 rupees. Are you sure you're willing to pay this much? This is the first quote request that goes out. Okay, give me a quote bhai for 10 assets. Why? Because if this did not happen and you simply placed an order, okay, bhai, I'm willing to buy 10 Axis, I don't care about the price. What if all these traders sort of remove their orders and you have to buy it at a very high price? To avoid that, to make sure you're not buying a stock at an extremely irrational price, there is usually a request that first goes out that gives you approximately, looking at the current order book, for 10 stocks, you'll have to pay around 200 rupees per stock. If you are okay with this, is when you send the second request to actually place the order. And if the order book changes drastically by then, the order sort of fails. If the first quote that you get, which could be, let's say 200 rupees, if the final order that you send after the quote, if the price that you're getting is not as good as this, because the order book moved by a lot between that quote request and the send request, the order does not succeed. This is to protect retail. You don't want to, blindly put an order, give me 10 quantities at whatever price, because you might get an extremely irrational price if the order book changes by a lot during that time. So this is one thing to keep in mind. Usually it does not happen in very liquid exchanges unless you're sort of, placing a very big order. If you're like, I don't know, I'll buy 1 million stocks of Tata, then of course you'll end up eating the order book a lot, and the price that you buy it at will not be this. It will be some price much higher than that, because you're eating up the order book a lot, and that is sort of the thing you keep in mind. But usually retail doesn't care. Retail buys really small prices, so it doesn't really matter. They end up eating a little bit of the order book. Liquidity and market depth. So as I said abhi piche ke, retail, if someone comes and puts in an order for $1 million, they'll end up eating the order book by a lot. What liquidity or the market depth means is how many orders exist on the order book. How can it handle big orders? Can it handle big orders without crashing the price? Which means there are multiple exchanges. As I said, there is Grow, there is Zerodha, and the liquidity on those exchange means how tight the spread is, how far is this, and how much quantity have people already put there. I'm willing to buy, I'm willing to buy, I'm willing to sell, I'm willing to sell. So that if a big order comes, how much price impact will come, how much the market will move based on a single whale coming in and putting in a big order. The less the price movement, the more the liquidity, the better the exchange is. More liquidity, better the exchange. Market maker provides liquidity. So question is, why would someone even provide liquidity? Like, why do I want to sit on this order book all day and wait for orders to come in? And the answer is, market makers are incentivized. The people who do this are the people who make a lot of money. The companies that you might have heard of that pay like 4 CR offers, like Citadel. These companies, they put in a bunch of orders on both the sides. They somehow find through like a bunch of mathematical algorithms, this should be the current price of Bitcoin. And then they put some orders which are slightly more than the current price and some orders which are slightly less than the current price. Whatever side it gets matched, they end up making money. And the reason they sort of take this risk of putting things on the order book is because they get incentivized, they get lesser trading fees, they get other sort of incentives by the exchange for making the exchange more liquid. So how do exchanges get liquidity? They go to market makers. They say, bro, please put a bunch of orders on both the sides. Please try to decrease my spread by as much as you can, because the less the spread, the more people would want to trade, the better price people will get. And what do they get in return? They get a bunch of things. They get general incentives. They get lesser trading fees. They also get, on this specific price, it might happen that there is a retail user who's put in money there, and there is Citadel. And when, let's say, an order match happens and the execution engine has to decide कि इसका order match होना चाहिए कि इसका order, it will most probably prefer the specific market maker. So they are like the algorithm that decides who should get matched at a certain price, considering, let's say, there are multiple people who've placed order at a certain price. That algorithm sort of is slightly skewed towards, and it's usually public. There are no shady things that happen here. It's publicly known that this algorithm sort of favors market makers a little bit more, people who provide liquidity a little bit more. The closer you are to the spread, the more sort of incentive you can get from an exchange. That is what providing liquidity means. These are things you have to worry about after you've built an exchange. Building an exchange is the simple bit. Getting liquidity on the exchange is the harder bit, because the more liquidity you have, the better prices you will have. The better prices you will have more retail come in. If more retail comes in, then they place a bunch of these swap orders pretty naively, and then you make a lot of money in trading fees. Cool. Let's understand one last jargon you need to know about, which is maker versus taker. So as I said, there are these people called market makers. Citadel, the big company that sort of puts a bunch of orders on both the sides. Whenever a trade happens, to sort of emphasize on this very heavily, whenever a trade is happening, there is someone who was sitting on the order book waiting for the order to happen. And then someone who came in and said, bro, okay, I will take this order. I will buy it off. The person who was sitting on the order book is who's called the maker of that specific transaction. The person who came in, placed an order and took away liquidity from the trading engine is called the taker. Who do you think an exchange prefers? Let's say you're a broker. You're dealing with two parties. One party is like, I'll only sell it for 45 lakhs. Other party is like, I will only buy it for 40 lakhs, nothing more. The broker knows that, yaar, dekho, fair price to is 42 lakhs. The broker comes to the buyer and says, sir, 42 lakh kar lo na. Please agree on 42 lakh. I will make the other party agree. You just say yes, you commit to 42 lakhs. And the person says, yes, okay, I will pay 42 lakhs. Then the broker goes to the other buyer and says, the seller, and says, okay, bro, you also decrease it from 45 to 42. And then the match happens. Who is the broker more happy with? Who will the broker give less trading fee? The buyer, because the buyer upfront put an order on the order book. Okay, theek hai. You take an order from me at 42 lakhs, it's fine, as long as you're able to convince the other party. So the person who's sitting on the order book all day waiting for an order, providing liquidity, is the person who is favored / given less trading fee when the order is executed. And the person who comes and takes liquidity from the order book is sort of the taker and is like the bad person in this sort of equation, because they came immediately, took liquidity from the system. The other person was sort of sitting there all day, gave out such a good offer to the order book. So this person should be incentivized, and that's exactly what happens. Let's look at the maker taker official bunch of points, and then I'll take you through the trading fees of a bunch of platforms. The person whose order exists on the order book is called a maker, hence the term market maker, because they sort of make the market. They have a bunch of orders above and below the current price. The person who gets their order filled is called the taker. Again, I will repeat this. If there are a bunch of people putting in orders on the order book, that never causes a swap to happen, that never causes a transaction to happen. The transaction always happens when someone comes and puts it, irrespective of whether they put a limit or a market order, but they will come and they will be like, okay, they will come in and they'll be like, I will buy at an X price or Y price. If something exists on the order book, they will take that liquidity away, else they will sit on the order book as well. So whenever an order is happening, there is someone who immediately got liquid. There's someone who immediately got what they wanted. They are called the taker, and the person who was sitting is called the maker. It never happens that two people at the same price be like, boom, let's exchange. There is always someone who's sitting. There is always someone who's come and taken the liquidity. Taker fee is usually higher than the maker fee because they take away liquidity from the book. If you look at an example, this is the Binance fee structure. As you can see, they have like separate maker and taker price. So whenever a swap is happening, the exchange is of course taking some fees in the middle, and that fees is like minuscule, so you don't really see it. But yeah, even if you're an order book, if you're on a swap page, irrespective of where you trade from, the exchange ends up taking some fees in the middle. And as you can see on Binance, it's the same if you're not trading too much. If you trade above a certain amount, you can see the maker fee is much lesser than the taker fee. always is the case that maker is less than taker. And why? Because maker is providing liquidity and taker is taking away the liquidity. Cool. Where does latency matter? We talk about low latency trading systems. We talk about these systems need to be extremely fast. Where does it matter for both the exchange and a trader? There are like two places where latency matters a lot. I'd argue it matters much more on a trader who's trying to make money from the exchange. The exchange just makes money on swap fees. That's their major sort of source of income. This guy is making money by arbitraging, by market making, by running a bunch of machine learning models to find the current price of a stock. This guy needs to have like really fast systems. But this guy also, if an exchange is like really slow, no one will trade on it. So what does an exchange need to worry about? Order placement time, which means when someone comes and puts a limit order or a market order, how quickly the orders get put on the order book. Time to fetch the order book. All these traders worry about ke bhai, show me what the order book looks like right now. So I can, based on that, do some mathematical modeling and understand ke how much are people willing to buy and sell for. Real-time updates on the order book. The order book never remains the same. It changes very quickly. If you open an order book on Binance, you'll see this sort of chart going up and down like crazy every few milliseconds. So they need to get these updates very quickly. That's the other place where latency matters a lot. For a trader, order acknowledgement time matters. Okay, one, to I put an order. Second, either the order reached the order book or it got filled or it got partially filled and the rest of it got put on the order book. I need to know this as quickly as possible. Order cancel time, super important. They are placing a bunch of orders on a bunch of exchanges. If the market moves a certain way and they need to cancel in like a specific order, the latency of the cancel request needs to be really slow, like really latency needs to be really small, which means it needs to happen like a few milliseconds. If not, they can like lose a lot of money because they made predictions a certain way and they need to cancel a few orders for them to sort of make money. And if that cancel takes 1 second, then of course they lose a lot of money. Their order priority. This is the thing that I was talking about. Okay, the person who provides more liquidity usually gets some priority when the orders are being filled. Okay, if there are 3 people that are present and one of them is providing a lot of liquidity, their order would probably get filled first and then the other people, because they've been providing liquidity. They also have like, exchanges have partnership with market makers. As long as you provide us liquidity, it's under a certain SLA. There's always like you're above and below 2% of the current price always. Then you'll get like some extra benefit. You'll always be the first person to get placed on an order, so on and so forth. So that's another thing that traders worry about when they're trying to deal with an exchange. How is latency made better for the exchange? Where do these engineers work and try to like decrease latency? Number one, how? Using faster programming languages. That's the reason why we keep saying C, C++, Rust, Zig are the languages that are used in exchanges, or like OCaml. No one uses Node.js there. Faster serialization and deserialization of data. The exchange is getting a bunch of orders. All of these orders are in the form of, okay, at price 200, I want to buy 2 quantity. Price 300, I want to sell 1 quantity. It needs to serialize this data, deserialize this data. The amount of time it takes to convert this data, which might be a string, into some other format matters a lot. And that's sort of one of the systems that these people working in an exchange work on. And lastly, in-memory order books. So what is an in-memory order book? It basically means you would argue, or you would think all this Binance order book is stored in a database somewhere, or like a faster database like Redis or in-memory cache. But the answer is it stores literally, it's stored, a lot of times it's stored literally in memory, which means if you have a Node.js application or a Golang application, the order book is literally a variable there. Why? Because if it's a variable there, it's much faster than storing it in a database. But what is the downside there? If the process ever goes down, your order book, you lose the order book. So there are a few ways to sort of recover an order book, and there are backend events that keep happening that give you a log of all the events that happen, so you can always recover. But the hope is the order book never goes down, and the order book is, everything is stored in memory, which means it's a variable in a Golang process, and it usually doesn't go down. If it does go down, you might have seen like Binance order book 1 USD ETH went down, or order book USD ETH 2 went down. And when that happens, you have to sort of run systems to read through logs, read through the last set of orders that were there, and finally arrive at the current order book and restart the order book. But believe it or not, as counterintuitive as it might seem, a lot of times order books are stored in memory and not even in like a database. How is latency made better for a trader or a market maker? So I've said this before, traders are sort of the place that make money, that are really worry about latency, because these are the people who are actually, the way they make money is through trades, and these people just make money through whatever swap fees. being closer to the trading server. If this is the world map, if this is where, the trading server is, the closer you are to it, the faster you can create orders. That is one thing these companies experiment a lot with, put a bunch of servers all around the world, measure latency automatically, and then the least latency is where they place an order from. Having multiple connection open. So all these servers have connections open, they keep sending orders and they keep measuring which one is performing the best. The one that is not, they close that connection. Fast serialization and deserialization, which is basically the same thing as here. These guys are also receiving a bunch of data from an exchange. So like the current prices, the current depth and the depth updates. They need to make sure they're able to read them fast. So here also a lot of work goes into understanding how you can deserialize data well. Now, it really depends on the exchange, how they're sending you data, but given okay, they're sending you, let's say JSON, or they're sending you data in a protobuf, or they're sending you binary data. Given that this, how can you serialize and deserialize it faster? What are the libraries that exist? Can you build a library of your own? Is there a certain library in a separate language that sort of deserializes data very quickly? That's where a lot of sort of effort goes into these companies. And lastly, faster oracles / prediction models. So as I said, these companies sort of, a lot of people are like not working on trading systems, but working on mathematical models. What they do is, there are a bunch of exchanges all around the world. It's exchange 1, exchange 2, exchange 3. They get prices from all these exchanges and try to predict, everyone will have a separate price based on their order book. They try to predict the current price might be 100.1. These are mathematical models that are running. The quicker they understand the current price, the quicker they can place orders everywhere. So what are the two important things to note here in the last point? It is one, getting data from oracles much faster, which is this part right here. And also the mathematical model that actually runs to find the current price of a specific stock. Lastly, building an exchange order book. That's what's going to be the next part of this video. We'll try to build an order book in Node.js ourselves, just the backend for it. Then we'll write some tests and see how things sort of work the way they do. And then finally, I have an assignment here, which is sort of an algorithmic problem. So even if you don't understand a decent chunk of the code base we're going to discuss, you can still solve the algorithmic problem as if you can write the code at a specific place. And once you do, the set of tests that are not succeeding should succeed. Feel free to create a pull request. The first 3 people who create a pull request with the exact solution will get 500 rupees per head from me. I'll just transfer them to your Google Pay. Cool. So what are we going to do from now on? We're going to write an order book in Node.js. The order book should support a user can place a limit order. If the order can be executed or filled partially or completely, the order will be filled. Users can query the current depth chart. Maybe another point I'll add here is user can get back their balance, which is like their USD balance or their Google stock, Facebook stock, whatever stock we're supporting, the balance of that. And then there is an assignment. I will explain the assignment as we go through the code base. So let's dive into the code base. Before we do that, let me give like a high level of how I would write a code base for an application like this. I'd probably create an HTTP server. The server that we're using today is called Express. Again, we're writing it in Node.js and the language is not JavaScript. Unfortunately, it is TypeScript, but TypeScript isn't too difficult to understand. I'll take you through the TypeScript bits like very slowly. So don't worry about if you don't yet understand TypeScript. It's just like some extra fluff on top of JavaScript. And what does the HTTP server need to support? It needs to support an endpoint that lets the user create an order. It needs to support an endpoint that lets the user query their balance. It needs to support an endpoint that lets the user query the depth. The order endpoint should take what as an input? As I said, the requirement was just to support a limit order, not to support market orders right now. Why? Because that is what this sort of assignment is. The order endpoint should take as input the side, which will be either the user is buying or the user is selling, the price at which the user wants to buy or sell, which will be a number, the quantity that the user wants to buy or sell, which will be a number, and then it should ideally take in like the ticker or the market that the user wants, like the whatever Google/USD. But in our case, we're just assuming there's a single market, like the order book only supports a single market. So we don't have to worry too much about it. I think these 3 inputs are enough. I might be missing something. We'll see. The balance endpoint. Oh, the user ID is what I'm missing. So there's no real concept of cookies or headers. We're just letting the user send in a user ID, which would be a string. And that sort of represents who is the user who's making the transaction. In the real world, you'll have like headers, you'll have proper authentication. We don't want to worry about any of that yet. These are the 4 inputs that the user can send with the /order request. On the /balance request, the user can send the user ID of the user they want to query, and they'll get back like their USD balance and their Google balance. Google is the market that we're sort of creating the order book for, the specific order book, and the depth endpoint, which would return the bids and the asks, basically the current order book and how does it look like. It could be something like at this price, whatever, let's say 200. This is the quantity, let's say whatever, 5 quantity, and then this is the bid side, and then similarly the ask side, so on and so forth. So this will be the order book. This will be the balance, and this will be the order. These are the 3 endpoints you need to support. The assignment will be if the user wants to place a market order, they first need to send the quote request to get back the current best price that they can buy it for. And then eventually they can just sort of place a limit order with that specific price that's equivalent to them placing a market order. If you get back a quote and then create a limit order, that's equivalent to you just buying off the order book and creating a market order. This is the assignment, but we'll get to it when we get to it. For now, let's try to create a simple HTTP server that supports these 3 endpoints. Let's get into the coding bit. All right, let's get into building an order book by ourselves. We are going to write it in the MERN stack, more specifically just Node.js plus TypeScript plus Express. There is no database we're using. It's an in-memory order book. There aren't any prerequisites for this section. If you understand how to write code in any language, I think you should be fine. If you know a little bit of Express, it'll help. If you don't know TypeScript but know JavaScript, I think you should be fine. Just ignore the TypeScript bits inside the code base. And as always, this code is sort of available on GitHub. So you can just go to github.com/Harkirat/trade assignment and look at the code base. It's a fairly small code base. Everything is like shoved inside a single index.ts file. And we also have some tests. These are the tests that currently run. These are the tests that will run if and when you solve the assignment. As I said, first 3 people to create a pull request, which makes sure that the assignment is actually passing, will get $500. That's rupees and not dollars. So with that, let's start to explore the code base. What we've written is a simple HTTP server. For those of you who don't know, HTTP servers are basically places where you sort of put logic that people all around the world can sort of access. So if someone sends a request to your HTTP server, they can be like, okay, I want to place an order. Or they can be like, I want to get back my balance, so on and so forth. So we're trying to create one such HTTP server. And the library that we're using to create it is called Express. Cool. Don't worry too much about the logic if you've not written HTTP servers before. It's not too difficult. All right. With that, let's look at the code base. As I said, there's a single file where we've written all of our logic. So let's go to the top of this file and see what all we've imported. At the top, I import Express and body parser. Feel free to ignore this body parser thingy. Just focus on Express. This is an HTTP server. What it lets you do is run a process that people all around the world can sort of hit on your specific machine. If I deploy this on AWS, then people can sort of interact with my program on AWS. And that's sort of how the backend of any exchange would work. I define a few interfaces here. If you don't know what interfaces are, they're basically similar to, they're like types of your data, the shape that your data should follow. This is TypeScript specific concept. If you don't know TypeScript, feel free to ignore all these, I'd say 10, 15 lines, because you don't really need to understand this. I wrote it in TypeScript. You could totally write the same code in just vanilla JavaScript and you'll be fine. But for the people who do know what TypeScript is, I've just defined a simple balances interface, which is an object which basically maps your balance for an asset. So your USD balance, your Google balance, your Facebook stock balance, so on and so forth will basically be an object. A user will have an ID and a list of balances. So what is a user? They have an ID. You could put things like username, first name, last name here. We're not worrying too much about that. And finally, the balances is the important bit, where every user has a bunch of balances associated. Things like they have 10 Google stocks, 10 Facebook stocks, so on and so forth. We'll see this very soon when we reach this section. And lastly, an order interface, which is how would you store an order that a user places that sort of should exist on the order book. The way you would store it is probably a user ID, a price, and a quantity, which means this user placed a limit order for this price and this quantity. More specifically, this will be the order that is left. So it might happen that the user placed an order for 10 quantity of Google stock at whatever rupees 500, but 5 quantity got filled. So by the end of it, this object will just store, the order object will just store 5 as the quantity and 500 as the price for this user. As the orders keep getting filled, this order object sort of updates as well. We will see that very soon. But again, these are just types. If you don't understand them, don't worry about them. I have defined a ticker variable, which basically is the current ticker that's trading, which basically means the asset that you're trading. In this case, it's Google. You could have multiple assets here. Ticker could be like an array rather than being a string, but our order book only works for a single market right now, which is why there's a top level variable that's defined. Okay, this is the market that you're trading with, and what is the asset you're trading against? It's USD, which is why if you look at the initial users array that I've defined, it is an array, and the balances that the user has, the initial balances that we've just given dummy balances to the users they have 10 stocks of Google and $50,000. Both the users have like similar balances. This is the assuming that somehow they on-ramped and put $50,000 into the exchange and they already have 10 Google stocks. This is sort of the initial assets that they have that they're trading with. Cool. So define a dummy users object, and I have an in-memory object called bids and asks. This is the sort of weird bit slash the bit that feels like, oh, this should be in the database. But as I said, most exchanges or a lot of exchanges that need to support low latency store order books in memory, which means they're literally just variables, and that's exactly what this has. There are bids, which is an array of orders. There are asks, which is an array of orders. This is the thing that I was talking about. Okay, whenever someone puts an order here, let's say they say I want to buy 10 stocks of Google at 500 rupees a pop, I would push to the bids array. Okay, this person wants to type by whatever, or I don't even need the type because it's in bids, but like this is the price that they want to buy on, and this is the quantity that they want to buy. And if when the user was placing an order, some part of their order got filled because there was some order in the order book that could be matched with, then the quantity that reaches here would be lesser. If the complete order gets filled, which means whatever price that they're sending in is already exists on the order book on the other side, the order will get matched. This order should never really reach the bids array or the asks array based on what kind of order the user is placing. Cool. So we'll see all of that very soon. For now, we have two arrays, bids and asks, and these just contain a list of open orders, which means an orders that have not been placed. This could contain two orders at the same price. So it's not what this order book look like. It's not an array of, price quantity. This is a cumulative representation. Okay, haan bhai, there are 2.7 Bitcoin available at this price. What we are storing is ki there is at this price one order for 0.7 quantity, one for 2 quantity, whatever, one quantity, and another order for 1 quantity. So our array will have 3 values. We are not storing this cumulative value, which is sometimes cached and stored in some exchanges. In our case, we're just having a list of orders that are currently open and available. All right. How will we fill the bids and the asks array? The answer is simple. When the user hits the /order endpoints, which means they're sending in an order, when will this endpoint get hit? It will get hit when the user actually goes to the UI and puts in a market order and presses the submit button, a limit order. This /order endpoint will be hit. Again, it will only be hit for limit orders. We are not worrying about market orders at the moment, just limit orders. And as you can see, the inputs that the user provides are, okay, this is my side. I want to either buy or sell. So this will be basically either buy or sell, or more specifically, it will be like a bid or ask. These are the two things that the user can send as an input here. The price that they want to buy it at, the quantity that they want to buy, and their specific user ID. As I said, we don't have any cookie logic here, any header logic. We just let the user send in a user ID, and we just assume that the system works with this security loophole. In the real world, you'd probably get the user ID from the cookie of the request and do some more fancy things. Right now, we're not worried about authentication. Simply worried about writing an order book that can store orders and match orders. Here comes an important line. Here I say, when an order comes in, I first need to check कि जो existing order book है, can this order be somehow filled on the existing order book? What do I mean by that? Basically, if the order book, let's say, has someone who's selling 2 at the price of rupees 500, 1 at the price of 499, and I say, bro, I want to buy 1 at the price of, I'll buy 1, I'll give 502 rupees for 1. So what will happen? Your order will get matched from the least bid here. Even though you said, bro, I'll pay 502. Since you are the taker, the maker is sort of the one whose price is considered. So if you ever, this is like general interview question slash, thing you should know. Okay. If the order book, let's say, only had 2 orders, basically 2 orders that were willing to sell at 499 and 500, and you came in and said, I will buy at 600, you won't really pay 600. You will only pay 499, and you will get one specific order, one specific stock, quantity of that stock. And if you're placing that order and the order book can eat up your order, then you don't have to actually put this order in the order book. If that is not the case, if I said, okay, bhai, I'm buying one quantity but for 399, then it will go in the order book here. Okay, someone is willing to buy at 399 and the match did not happen, there is still a spread. So these are the 2 cases we need to consider. If I go back to the screen here, you can see I first check, okay, can I fill orders, and I get back a remaining quantity number here, which is like how much of the quantity is left to be filled. We will see what this function does later on. Let's not worry about that right now. Assuming that this function does what it says, which means it actually flips the user's balances and matches the orders that can happen, and returns back a remaining quantity variable, which means the amount of quantity that's left to be filled. If that quantity is 0, it means that the order has been filled. We don't have to put anything on the order book, and you can simply return filled quantity equal to quantity. This is something that traders expect to get back when they're placing an order. They want to know how much of it got filled and how much of it is still remaining. In this case, the complete quantity got filled if remaining quantity variable here is 0, because what is this variable? It is the quantity that is left that the order book was not able to process. For example, if let's say I place an order that says, okay, bro, I'm willing to, the current order book looks something like this, and I say I'm willing to buy 3 at 499. So how much of it will get matched? One order got matched. Okay, Harkirat bought one stock for 499. This order sort of went away, and the other 2 orders sit on the order book now. So the order can get partially filled. That's exactly what happens in this case. And when that happens, you sort of proceed to put the rest of the quantity in the bids or the asks array. So as you can see, what do? I say bids.push this user ID at this price wants to buy this much quantity, and vice versa. This user at this price wants to sell this specific quantity. And I'm doing something special here. I'm sorting the bids and the asks array at the very end. Why am I doing this? It's just eventually we have to match orders. So what I want to do is, okay, whenever we're matching orders, I want the bids to be sorted a certain way and the asks to be sorted a certain way. Basically, I want to make sure that if there is the bids array, it should finally be sorted by price. Okay, the maximum that someone is willing to pay should be here: 500, 499, 399, 399, 399, 398. Why are these repeated? Because different users can put like 1 to 1 here. And as I said, our bids array is not a cumulative of 399 pay this much quantity is present. Our array is 399 pay one user has put this much, other user has put this much, another user has put this much. Same user might have put 2 different orders. They're all stored separately in the bids array, and it's sorted in this fashion. Okay, by 500, the thing that would appear at the top of the bids is the last value here. And what about the asks array? In the asks array, I would put the least value here. Okay, someone is willing to sell it for 501, and someone is willing to sell it to 502, 503, 503, so on and so forth. This is how I'm sorting the bids and asks at every point. Is this optimal? Probably not very optimal. Is there a more optimized way to do it? 100%. If you know bids is already sorted and the thing that's coming in sort of needs to go somewhere here, you can do binary search, you can do a bunch of fancy algorithms here to sort bids and asks. I haven't done it, but by the end of it, the order will either completely be filled, or if it is not completely filled, if it is either partially filled or not filled at all, the order will exist on your order book, either in the bids array or the asks array. Let's say that there are 4 users who placed a few orders. You have 2 bids and 2 asks. The next important endpoint is the depth endpoint. We will still go through this fill orders function eventually. Let's first look at the depth endpoint, and then we'll go through the fill orders function. The depth endpoint, what does it need to do? It needs to return the current order book. It's as simple as that. So the only extra logic you need to add here is, as I said, okay, these are not cumulative requests. So when the person asks for a depth, they need to know cumulatively how much quantity can I buy at a certain price. They don't want to know 200 pay there is 2, and then 200 pay there is also someone with 3. They don't want that. They want to know simply 200 pay there are 5 quantities that I can buy. So we need to sort of just cumulate them together. For that, I have written this logic. Okay, how do I define the depth? This is again TypeScript. If you don't understand TypeScript, feel free to completely ignore this part. You can simply assume it to be const depth equal to an empty object. If you do understand TypeScript, I'm saying the type is, it's an object where the key is the current price at which depth, a bid or an ask is present. The type, whether it's a bid or an ask, and the quantity, which is the cumulative quantity of all orders. If there are 3 bids at 500, I want the cumulative quantity to be returned to the front end, because when the user sort of hits this endpoint, they want to see a graph that looks something like this. That is why the user is, let's clean this up. The user is hitting this endpoint because they want to eventually see this graph. So they just want to know the cumulative quantities. So they don't want to know, okay, this pay there are 3 people. They want to know this pay, it is this much quantity that is available to be bought. So that is what we're doing in this endpoint. We're accumulating the depths, the bids and the asks. The way we do that is we iterate over all the bids and we check if depth of bids of I dot price, which means if this specific price already exists on this depth object. If it does not exist on the depth object, we initialize this specific price key and we say the quantity is this specific bids quantity and the type is the bid. Versus if it already exists, if some existing bid already existed at this price, you simply add the quantity of the current bid to the existing bid. You go through this logic again and again. Is by the end of it, you will have the depths array with a few prices and types of bid and the cumulative quantities at those prices. And the same thing we do for asks. Okay, we iterate over all the asks. If there is nothing that exists at this price, we initialize this specific price key and we say the quantity is asks of I dot quantity and type is ask. If it already exists, which means there was another ask at this specific price that we have already iterated over, we simply add asks of I dot quantity to the existing quantity. And by the end of it, we get the net depth that we can return to the front end. This is how the slash depth endpoint is created. We will see what response it returns eventually, but at a high level, the response needs to be very similar to something that can show this on the front end, which means a bunch of price, quantity, and type, an array of this. An array of these elements, which has the price, the quantity, and the type. If the type is an ask, it will go up here. If a type is a bid, it will go up down here. That's the second endpoint. If the third endpoint is the balances, which means how much balance does this user have of both USD and of Google. These are the 2 balances that we support right now, the 2 assets. The way we do that is simple. We get the user from their user ID. We expect the user to give their user ID in the params. So if they hit /balance/: user ID, which means /balance/1 /balance/2 with a get request, we get the specific user. If the user does not exist, which means as you saw initially, we only had 2 users. If someone sends an ID of 5, we return them an empty balance on both USD and Google. This bracket ticker bracket close basically means this will be replaced by Google. And if that user does exist, we simply return the balance of that user. So what would you see initially? As you can see, initially the balance of first user is 10 and 50,000 and the second user is the same. So initially when I hit this endpoint, I will see 10, 50,000. Eventually, as we place orders, these numbers will go up and down. If you look at the tests, let me show a test really quickly. The very first test, I think, is a test that validates the balances. So if I look at index.spec.ts, as you can see, the first test says verify initial balances. It sends a request to /balance/1 and ensures rest.body.balances of ticker is 10, which means the user has 10 of Google stocks and the user 2 also has 10 of Google stocks. I can put another check here to check rest.body.balances of USD. That should be 50,000. That's the initial balances that the user has. So I hope the balances endpoint is straightforward. This is the assignment. I'll come to what it is. Don't worry about it. Now let's look at the main function, which was if you looked at the order endpoint, I had a function there called Fillorders, which was basically before we put anything on the order book, we need to make sure if an order can be matched, we should match it. Only if there is a remaining quantity, should that quantity be put on the order book. Question is, how do you fill orders? What is the logic that actually matches an incoming order with an existing order that exists on the order book? So let's look at the fill orders function. What does it accept as arguments? It accepts the side, the order that is being placed. Is it a bid order or is it an ask order? The price, how much, at what price is the user trying to place an order? The quantity that the user wants to buy or sell, and the ID of this specific user. Then we say let remaining quantity equal to quantity. So this is, we initialize an object called, not an object, a variable called remaining quantity with the current quantity that needs to be filled. And if the side is bid, what will I do? I will iterate over the asks. I repeat, if the incoming request is a bid, which means someone is bidding. If let's say this is what the order book looked like at some point, and someone said, bro, I want to bid, I want to buy one Bitcoin at 28312.11. Where should this be matched? This is a bid. I want to buy. So this should be matched with the asks. Is someone willing to sell? This is a green order. This is the person wanting to buy. It is a bid. What will it get matched with? A red order, someone who's willing to sell. That's how the swap will happen. So the function we're looking at should iterate over all these bids, more specifically just the bids where the price of this thing is less than equal to this thing or greater than equal to whatever. I think you can do the math and try to match it with them. It should start from the very bottom. It should see what is the least amount that this user can pay to get an order matched. And if they can, you should match that order. If they cannot, then you should basically not match the order. And if they can partially do it, you should match as many as you can and return whatever is left in the remaining quantity variable. Let's look at the code to understand this slightly better. At the top, I say let remaining quantity is quantity. This is the quantity that's remaining to be filled. If the side is bid, which means I'm trying to buy, we iterate over all the asks from the end. Why from the end? If you might remember, we used to sort the bids and asks. How were the asks sorted? The asks were sorted from top to bottom right here, which means I said the last variable will be this guy, then there will be this guy, then there will be this guy, so on and so forth. If a bid is coming in, it should first be matched with this, then with this, then with this. The user should get the best price that's available on the book, which is why we iterate from the very end and then go to the top. And we say if asks of I dot price is greater than price, which means the ask that someone has, I to will give it on this much only. If that's greater than what this person is willing to buy it from, then you can't do anything. We say continue and the for loop continues. If, however, and you can also just break here if you understand algorithms a little bit, you can just break here because if there is a certain price at which you cannot match the order, anything above that you can't really match. So you can actually just break here, but continue is also fine. If, however, the asks of I dot price is less than equal to the price, which means there is an order on the book where the user is asking for a price that is either less than or equal to this price, what will you say? You'll say, okay, perfect. Now I can actually do a flip. I can actually match the order. So what do we do here? We say if asks of I dot quantity is greater than remaining quantity. So for this specific ask, if the quantity is greater than remaining quantity, which means this is the quantity that's remaining to be filled, and this ask has a lot of them. Let's say someone wants to buy one share of Google for 10 rupees and on the order book at 10 rupees, 100 shares are available. Then this logic would hit कि हाँ भाई फिर तो asks of I minus equal to remaining quantity, which means one ask got filled. There is still, the ask will still exist on the book, but the quantity of the ask went down because someone took away some. And then we call flip balances. This is the important thing. We actually flip the balance between the user ID on that specific ask and the user ID that's trying to place the order. We try to, the asset goes from one side to the other side. The USD goes from one side to the other side. And that's sort of what the flip balance function does. As you can see, this most probably should be asks of I dot price and not price. I think there's a bug here, but it's fine. Google it, or not Google it, like try to think, should this be price or should this be asked of I dot price? I think it should be asked of I dot price. But either way, our tests are like not enough to sort of test this, but when I was thinking through it just now, I realized this should probably be asks of I dot price. What does flip balances do? It says by user 1 and user ID, a flip has happened between them on this quantity and this price. We know there's just one ticker right now, Google. So we need to decrease this quantity of Google from the first user, add that quantity to the second user because there is a swap that just happened. And what about the US dollar balances? Quantity into price is what gets added for the first user and removed from the second user. Why quantity into price? This is the price I want to buy it on, 200 rupees, but I want to buy 10 shares. So how much money do I have to pay the other side? I have to pay them 200 into 10, right? I have to pay them 2000 rupees, which is why the US dollar that will get debited or credited to the other side will be price into quantity, but the value of the stock that will get debited and credited will be just the quantity. That is what this function does. And this happens if you ever reach, this happens like this if case hits, if let's say This was the current order book. And the order that came in was कि हाँ भाई, I want to buy 28312.11 पे just one quantity. Then you know कि हाँ, this will get filled completely, which is why you will just do a -1 here, and this will become whatever 1.7688, and then you can just continue. But if that did not happen, if the order that is placed was for 5 quantities, then you have to remove this specific bid, this specific ask from the order book. You will still match, but this ask now goes away. This has been completely filled. If an ask is completely filled, it no longer needs to exist on the book. Again, this is cumulative sizes. What we're discussing here is individual orders. So one of those individual orders will get removed if the remaining quantity is greater than asks of I dot quantity. If what is left to be filled, ask order is currently less than that, we will completely remove this order. We will flip the balances still, but remaining quantity will not become 0 now. The remaining quantity will be so here we return 0 because we know the complete order got filled. Here we say remaining quantity minus equal to asks of I dot quantity. There is an ask that was able to fill this order partially. I'm going to remove that from the remaining quantity. Flip the balances. What should the quantity be? This is the quantity that got filled, not the complete remaining quantity. So this is the quantity that will be flipped. And this will also, I think, be asks of I dot price for this to be completely accurate. Lastly, I do a asks.pop here, which means I will remove this specific ask. This ask completely got filled. So whoever was this user, they had an ask on the order book, their order has been filled, which is why we can remove this ask. We also flipped the balances. So that user also has their more US dollar now. This user also has more Google stock now. Both the parties are happy. They did an exchange on a specific price. This is just the bid size. The ask side is completely opposite. If someone comes and says, I want to sell, we will first check on the bids side whether or not an order exists and whether or not the price is right. If it isn't right, we continue. We could break here as well. If it is right, we check if the specific bid can completely fill the order. If yes, then we return 0 and we flip the balances. If it cannot completely fill it, we pop the bid and at least fill this specific bid, and then keep going from there, keep iterating to find more bids that might be able to fill this order. That is what the fill order function does. By the end of it, returns remaining quantity, the quantity that's left to be filled now. And if I look at fill orders and where it's called in our app.post/order. Before we put anything on the order book, we first try to fill as many orders as we can. We get back a remaining quantity, and that remaining quantity is what we, if that is 0, then we're good to go. We tell the user here thing was completely filled. If not, we push the remaining quantity on the order book, and 2, return to the user, bro, your filled quantity is quantity minus remaining quantity. This much got filled. Some of it is still on the order book. It might eventually get filled. Cool. That's the /order endpoint. Hopefully that's clear. Depth we have discussed, returns the depth to the end user, and the balances gives the balances for a user. Quote is what needs to be done in the assignment. I will explain that at the end. Flip balances, I hope we understand, and fill orders also, I hope we understand. This is a basic order book code. As you can see, less than 200 lines of code that lets user place orders, put the orders on an order book, get the current depth of the order book, place orders and actually get them filled, check their balances for a single ticker, a single market. This code will become slightly more complex if you want to support 5 different markets. But for now, Google USD is the only market we support, so the code is slightly simpler. Cool. Let's look at the tests and what we exactly test when we're trying to hit this. What are tests? It's just a way to test backend code. You could totally write a front end for it, give user buttons and click on buttons and see orders being placed in the backend. Or you could just write tests for it, which just test that the functionality is working correctly or not. In our case, we look at the tests. The first request goes out to verify the balances, which we already did. The balance for the first user and the second user initially will be 10 and 10. Then we create some orders. They should say can create orders. And there we try to send a post request to /order. The first request that we send, let me also visualize this here. After the first request, the bids array looks something like this. Price 1400.1, quantity is 1, and user ID is 1. This is what bids looks like after this first request. And then there are 2 ask requests that we send on, one for 1400.9, one for 1500.1. As you can see, this shouldn't match. They're pretty separate. The person who's trying to sell is selling at a much higher price than what one person is trying to bid, which is why we will have a proper order book. No orders have been matched until now. And if I look at the order book after both of these, it will look like this. Bids are these and asks would be something like price 1400.9 and quantity would be 10 and user ID would be 2. That would be the first one. Second one would be start with price. It was 1501. Quantity was 5 and user ID is 2. One peculiar thing to notice here is user ID here is 1 and here is 2. For both the asks, the user ID is 2. For bid, it is 1. When you go to like real world applications, people sort of try to trade on both the sides, and you have to do something called self trade prevention to make sure that a person will place orders on both the sides. Doesn't mean you match them with themselves, and prevent them from placing orders that would match them with themselves, because they're trying to conflict themselves if they're trying to create 2 orders that will sort of match. This is what the order book should look like by the end of it. The only tests we run here is we check that the status is 200, which means, the last thing we do after we send these 3 requests is we send a request to get back the depth, and we make sure that the request status that we get back is 200 and rest.body.depth of 1501.quantity to be 5. We can do other checks here. You can check what is the depth of 1400.9, what is the depth of 1401. We can also check the type here. You can do a bunch of things. The only thing we checked is 1400's quantity should be 10, should be 5, which is this thing right here. Sorry, 1501's quantity should be 5 because that's the quantity that we put, and we know there is no order that would match it. So this should exist on the order book as such. What is this logic right here on the iPad? It is this specific order that we're trying to compare. When we get back the depth, we will get back 3 values. For 1501, the quantity should be 5 because that's the quantity that currently exists on the order book based on the orders that we have placed. Ensure that the balances are still the same. No order should have been matched until now, which is why we send a request to check the balances and make sure the user still has 10 of the ticker stock, which is Google in this case. Then we place an order that actually fills. So we send an order from user ID 1, which means we're going to send another bid, but this time on price 1502. Okay, bhai, le jao. I will buy it at 1502. What should happen? How much quantity should get filled? We're saying quantity we're sending in at 2. The price we're sending it as 1502. So if I go back to iPad here, I'm saying bro 1502 pe le jao, which means it will be green. This guy says, okay, I already have an order on the book. I know no one's buying it for this much. No one's selling it for this much. So I will buy 2 at what price? 1502. When this hits the order book, which of these orders should it hit? Should it hit this guy right here? Should it hit this guy right here? Or should it just hit, should it just debit 1502? The answer is, it should hit this order right here. And this order is what should get matched ideally. But if you remember, I told you guys that our code has a small bug. Okay, yahan pe we're sending in price, which means the taker when comes in, they say I want to buy at a specific price. We say we swap at that specific price, which means in this case, when the user sends in 1500 to, that is the price we will swap balances on. But we shouldn't swap balances on that price. We should actually swap it on this price, which is 1400.9, because that's sort of the maker price, the person that's already existing on the book. The best price is what you give to a person, irrespective of someone says, bro, I'll buy Bitcoin for $1 million. You still tell them, bro, the best order on the book right now is $25,000. Please buy it for $25,000. You don't, even though the user is willing to pay $1 million, you don't necessarily, take that much money from them. You say, okay, what's the best order we can get? You fill it with that order. So this should have been filled with 1400.9, but our code base has a bug, which is whatever the price the user sent, which in this case is 1502, that is what we called flip balances with. So flip balances will actually put, 2 quantities here and 1502 into 2 here, which is like 3004. But ideally, what should it have put on the other side? What I was saying was, when I call flip balances, I call it with this price, the price that the user sent, which in this case is 1502, which is not right. It should ideally be asks of i.quantity, which would be 1400.9 or whatever, which is the right price at which you should swap. Now our code base, our code base, and that's something you should fix with a pull request. That would also change the tests a little, because the tests right now assume, as you can see, when we query the depth again, we do a rest.body.depth of 1501.quantity to be 3. So there's another bug in our code base, which is what did this order get matched with? It should have ideally gotten matched with, oopsie daisy, sorry. So what I was saying was, after we place the order, we send the order to be placed on the order book. We say ensure order book updates. We check the depth of 1501 should have gone down by 2. But ideally, what depth should have gone down by 2? It should have been this guy right here, because this is the better price. This is the worst price. This is where the match should have happened, which basically comes to tell you, okay, we're not sorting bids and asks correctly. What exists at the end, what I was assuming exists at the end, is not the thing that exists at the end. What exists at the end is like the opposite of it. So you should basically flip the sorting algorithm here. These are all assignments I'm leaving. I would love to say I left them by choice, but sure, this was a mistake, and I wrote these tests very quickly. But yeah, you should fix it, which means I think the few fixes that you need to make is: 1, sort bids and asks correctly. I think they're being sorted the wrong way. 2, fix the tests. Ideally, the thing that should be go down by 2 when you send an order to be filled by 2 shouldn't be 1500, which is this order. It should ideally be this order, because this is the better price at which this user ID 1's order should get matched on. So this should change as well. And lastly, ensure balance updates, which should basically make sure the flip actually happened, the order actually has been placed, and the balances have been updated. What should the balance updates be? This is still correct. Google should go up by 2 for one person. Google should go down by 2 for the other person. This is incorrect. The US dollar balances should be 50,000 minus 2 into 1400.9, which is the best price that the user can find, which is this thing right here. This is the best price that the user should get matched on. It got matched on a different one because, well, our logic here in the fill orders is incorrect because this price variable is incorrect. Log here, put a bunch of logs, figure out how to fix it, but there's like a bunch of bugs here that actually have left to be filled. I'm going to mark them as issues. Feel free to fix them. So this test would change, and by the end of it, you would have a new test suite. But I hope at a high level you understand what the code looks like, what bugs are left there that you can fix, and the assignment, which is, right now, how long was I on the iPad? Okay, I'm going to repeat a bit. What I was saying was, the other endpoint that the other test that we hit are, after you've placed an order that actually fills, we get the depth and make sure whether or not it updates. And this should ideally be 14.09 that goes down by 2. And we ensure that the balances of the user actually update, which means this balance should go up by 2. This balance should go down by 2. That is fine. The 2 quantity of Google have been flipped. But what was the price they were flipped on? The price that they should ideally be flipped on is 1400.9, which is this price right here. So the US dollar balances for the first person should go down by 50,000 minus 2 into 1400.9. The other person the person who sold Google should go up by 50,000 plus 2 into 1400.9. That's the other fix that needs to happen. Right now, there is a bug in our code base. What is the bug? This is one bug right here. This should be something else. I don't know what you have to figure out. And the other bug is the fill orders function, I think, is not sorting bids and asks correctly. Oh, sorry, not the fill orders functions. The /order endpoint is not sorting the bids and the asks correctly. I think that's sorting it the other way. So how do I know this? I know this because I have 2 orders on the book currently, 2 bids that are available. And the bid that it got matched with was this 1501 bid, but ideally it should have been matched with this thing. How do I know it got matched with 1501 bid? Because if you look at the tests here, I checked 1501's quantity went down by 2. But ideally, what quantity should go down by 2? It is the 1409.9 quantity. Cool. So that's the brief of what are the bugs in this code base right now that you should fix. I will create issues here and feel free to assign them to yourself, fix them. And the assignment now is, I will create issues over here. Feel free to assign them to yourself and solve them. The assignment is, we only have a market order right now. And there is a endpoint that's sort of yet to be implemented, which is the quote endpoint. The user will hit this with a market order. I want to buy 10 stocks of Zerodha or like Google. This endpoint needs to return, this is the price for each stock, or the average price of each stock if you want to buy a Google stock, or like 10 Google stocks. How will it do it? It has to go over, the other side, figure out how the orders will get filled, get like an average price and return it to the user. And then once the user has that average price, that user can effectively just hit a market order with that quote price that it got as the limit price. I will repeat. This is like one way to sort of do market orders is, okay, bhai, when the user is doing a market order, they're sending, bro, I need to buy 10 stocks. You have to return them, you can buy 10 stocks. Each will be available to you for 200 rupees based on the current bids that are present on the current asks that are present on the book. So what you can do is you can say, like, okay, I'm going to send you a limit order with 10 as the quantity and 200 as the price. The server said the order book can support this. So if you send back this limit order, it will immediately get placed. And if the order book changes by then, it's totally possible because, a bunch of orders happen and 200 quantity is not enough. This order will fail. You can send, ideally what happens in the real world is you send another argument here called the type of the order, which will be FOK, which is fill or kill, I think. Either the whole order, full or kill or something like that, or some other thing, I'm forgetting the name. But you basically say either the whole order gets filled or this order gets cancelled. This order never reaches the order book, which is how you can sort of simulate a market order. Okay, number one, send a quote request, get back a quote. Number two, send a limit request with FOK set to true, or like the type set to FOK, which means either fill the whole thing or cancel the order. And that's how you can simulate a market order. But again, it's an assignment. Feel free to try it. You will not learn anything if you sort of don't code yourself. So strongly urge you to, go through the code base a little bit, make the changes. As I've said, there are bugs here. I'm going to file issues right now. Try to fix them. And yeah, let's change the bounty a bit to, not the first 3 people to do that, but like first few people who fix these issues that I've mentioned, actually understand how they're fixed, will get 500 rupees each. With that, hopefully this was an insightful video. Let me know what you want to see next. This video was the part of the 100x Devs YouTube bootcamp, where we're putting out a bunch of videos that are on topics that are hard to find on YouTube and lead to high-paying tech jobs. So let me know if this was insightful. Let me know what you would like to learn next, and I'm happy to make a video like this on that. With that, I'll see you guys in the next one. Bye-bye.